Thank you very much. So, for the next 30 minutes or so, Dr. Steve Rogers, also known as CAP, and I will provide a quick overview of our perspective on the invention, development, fielding, and sustainment of trusted autonomy and AI at scale. And we'll do this in a conversation format, asking each other's questions, and I'll start with the first question. So, Cap, when I started at AFRL, you and your team were putting the finishing touches on Dr. Zacharias' Autonomous Horizon Volume 2. I think it'd be great if you could give us a brief summary of this important document and explain how trust and scale for autonomous system were envisioned in Autonomous Horizon Volume 2.
Autonomous Horizons Volume 2 was a document we were asked to put together with the Chief Scientist's Office, Dr. Zacharias. The goal was to articulate a vision, a way forward, if you will. And what the DoD wanted was a vision that could be used by senior leaders to understand mission implications, but also by bench scientists to sort of see paths forward in their very specific area. Unfortunately, we wrote the document in just a couple of weeks, about the time we met JC, but by the time we got it through the Pentagon, it's over 400 pages, so I wouldn't read it lightly, but it is an interesting document. And one of the things for this particular workshop, you should note that in the very first recommendation, we emphasize trust. If we're going to field these systems, and as we field these systems, we need to field them with trust being our number one concern. And we actually talk about the characteristics for trust, justified trust systems, not unlike what Eric talked about the other day when he was reviewing the National Commission study. But with respect to our vision of where these systems are going to go, they're aligned along 5 strategic goals, which we've also articulated in the DoD AI strategy. I just see the slides are coming up in just a moment. That's okay. I'm happy to tap dance without them. So the 5 strategic goals are, the top 3 are the ones I'd like you to focus on if you're a business out there and you're looking to get involved. Number 1 is enhancing mission and ensuring mission effects. So specifically, we have an effort going on, which I'll talk to you more about later, in terms of AI bots actually controlling platforms, whether they be air or space platforms. The second is enhancing multi-domain situation awareness, exactly what you might think. How do I take all these social media posts with all these national technical means, with all this commercial data, fuse it all together to do sense making? And then if you go down a slide, and then the third area is one of revolutionizing business processes, and so we do a heck of a lot of work in doing things like monitoring contracts, helping civilian hiring, et cetera. We do this with an organic team. Autonomous Horizons Volume 2 suggested you can't buy your way to dominance in your market sector. You need to grow your own, if you will. And so we have our own organic team of gubbies, and we work intimately with our contractors. We sit next to them, whether it's virtually in these sorts of meetings, or they sit next to us in the office space. It is an organic team which is developing government-owned solutions. And we do this using what we call our ACES platform, the Air Force Cognitive Engine software platform. And we'll talk more about that later, but it's important that you realize that we've adopted this platform business model and a platform technology solution. And then the last point I'll make to just sort of tie the vision together is we're a strong believer in conclusions like in the Belfort study, which I also reference at the bottom of this slide. In that study, they looked at transformational technologies over the years, things like aerospace as a whole, nuclear power, cyber, biotech. And what they found was there's the common development thread for a while, but then there's this bifurcation where national security needs are unique. We believe strongly that there's some very unique AI and autonomy national security needs, and those are the ones we're focusing on in AFRL and Act 3. So given that sort of background, if you go to the next slide, I've asked JC to sort of give you an idea of how does he look at AI solutions when people come to us or when internally we have these own discussions. So JC, if you could lead us through that.
Certainly. As Denise explained in the introduction, I advised the commander on the autonomy portfolio at AFRL, and my job is to go and review some programs, and I'll give you my cheat sheet. But before I do that, I'll go back and explain how I view autonomy. And as you know, I like to define autonomy as a freedom of selecting a course of action to achieve a superior's objective. It's not your own objective you're trying to achieve when you do autonomy. That would be independence. And we all know the difference between autonomy and independence. I mean, Cap, I'm sure you've never been invited to a autonomy barbecue day or barbecue autonomy day, on the 4th of July, or we've certainly never seen an RFP for an independent missile. So that difference is fundamental because it really puts the human in the middle of the autonomous system, and that means that we need to remain in control of the autonomous system, but it also means that we remain responsible for the autonomous system, and all of this is really done on the basis of trust, right? We do not grant autonomy. Independence is taken, autonomy is granted. And we don't grant autonomy unless we have that trust. So it's a really fundamental aspect. So with this in mind, I'll give you my kind of the framework I use when I evaluate programs. And it's depicted on that picture here with 3 pillars and a foundation. And the first pillar is algorithms. And under that pillar, you find things like perception algorithms, right? The sense making of the world. So you'd have perception algorithms, fusion algorithms, so trying to understand the world in which the autonomous system functions. Then you have the decision-making algorithms that take the commander's intent and decompose it into a set of executable tasks. So you have scheduling and planning. Those are the type of algorithms you would find in that branch. And finally, you have the execution. So, actually conducting those tasks and monitoring them and so on. So these algorithms can be relatively simple, as others have mentioned, maybe if then else statements, but it can also get very, very complicated. And it really needs to be adjusted for that. Yeah. The second pillar, the center pillar, is really the human system interface. And that's how we bring the human in the picture in the autonomous system. That's how the commander's intent comes in. That's how we validate that the autonomous system plan is going to achieve our intent, and that's also how we monitor the execution of the program, because as we know, it can not meet our intent eventually. And the final pillar is trust. And like I said, trust is fundamental. You do not achieve autonomy unless you have trust. And in that pillar, I would lump things like the test evaluation, validation process, but also formal methods and even ethics. Because when you think about trust, many different groups will have different perspective on what it's going to take for them to allow the use of the system, which is the bottom line of trust: is will the system be used? And maybe not just be used, but will used appropriately. Because too much trust is not a good thing. It can lead to catastrophic results as well. And finally, and maybe most importantly for this conversation, is the foundation. And this is what I call an open environment. Mark Lindemann earlier today mentioned the platform concept. It's the same idea. It's what connects the ecosystem, which includes large businesses, but also small businesses, academia, labs, to those pillars. And in that open environment, it starts with usually a government-owned open architecture, a DevSecOps environment, but it also includes things like data, large data sets. We don't want everybody to reinvent that. We want to be able to provide that and enable companies and businesses to use that. Modeling and simulation, tests, et cetera, et cetera. So this, foundation really is there to connect the rich ecosystem to the rest of the enterprise and achieve the autonomous. And I think, Cap, you've been working on a really interesting example of that foundation, of that open environment. And maybe you can give us more information about the Air Force Cognitive Engine and how you've developed that using small businesses. So next slide, please. Thank you. We can't hear you, Cap, if you're speaking.
You got to learn to read lips. You know. That,
I would, but my screen is really small.
So the first thing we figured out as we started embarking on Autonomy Capability Team 3 is even though a lot of us had experience in DevSecOps, you know, there really did not exist a really good environment for AI/ML DevSecOps, and so we realized we had a hole. And even if we had glommed onto some particular open approach to doing that, we didn't feel that it was moving fast enough for us. So we embarked upon this effort to create our own, and we call it the Air Force Cognitive Engine software platform, ACE. And this is, again, as I say, was originally developed for our own internal researchers to do their work on. But our vision is that we're exposing that to more and more people. So, for example, we fielded it up at AFIT now, the Air Force Graduate School. So those students are banging on it. We've put it up in the labs in the Sensors Directorate. Those people are banging on it. We'll be fielding it up in Rome. Those people will be banging on it. They're going to be using it in Mark Lindemann's machine learning boot camp. So it's very exciting to get this out there and in the hands. We have it running on our own hardware on-prem, but we've also fielded it in cloud environments. And so our vision is to turn this loose on the world for lots of reasons. But the most important reason of all is it's my firm belief that the only way to do the sort of things that we all are talking about doing at scale is if we get them in the hands of Airman Snuffy. And so our vision is although ACE currently is a tool that you have to be a pretty good AI/ML person to do it. And I do say AI/ML, it's not just for machine learning. We do lots of other stuff with it that are from the other AI religions. I have never been out in the field where they don't trot out some 18-year-old kid who wired together some Excel program or Java or Python script and solved some problem that nobody had ever solved before. Our vision is that we're going to put ACEs in those Airman Snuffy hands, and they're going to wire up AI and ML solutions that none of us have any idea that's a good application. And that's going to be our enduring asymmetric advantage, is having this platform, which again, we're turning loose, government owned. Right now, if you want to use it, you almost have to be in bed with us, one of our people, but we're pushing it out just as fast as we can, like through that boot camp. But we're going to put this out there, and we're pushing towards DIY AI. I mean, that's our vision, is to get to that place in the world. And the reason is because, you know, trust is, as I said from the very beginning, is on the top of our list. And so if you go to the next slide, JC is going to give you some feel for why it's so important to us, and not only at the national level, but then also just within the AFRL ecosystem. Go ahead, JC.
Yeah, thanks. And I love, you know, this do-it-yourself AI, paradigm, and hopefully, you know, I'll explain why it's so important in the next slides. And you know, after the end of the Cold War, you know, the U.S. emerged as the only superpower on the block, right? And we kind of assumed that great power competition was a thing of the past. Well, in 2014, we started to see big changes. With China becoming more assertive, and with Russia illegally annexing Crimea, we started to reassess our strategic assumptions. And at that time, the then Deputy Secretary Bob Works, who you can see sitting on this picture, started to talk about a concept he called the third offset, and was in reference to the first and second offset. I won't go into that right now, but the third offset was the latest, attempt to maintain, technical superiority and achieve, military superiority through that technical superiority. And specifically for the third offset, it was really to improve our battle network performance. And the primary, tool to do that was autonomy and AI. And so this really elevated both of those approaches to the level of strategic, national strategic importance. And this carried through the two administration changes. It's an essential element of the National Defense Strategy, which continues to be a guiding document. And recently, our new Secretary of Defense, Honorable Lloyd Austin, gave a speech where he fully embraced the use of autonomy and AI for data-driven decisions and human-machine teaming. But he also, made sure that we do this within, the values that we represent as a society, and that we would do that safely and securely. And he really emphasized the element of trust in this. So this is not new. I mean, and many other speakers talked about this over the last 3 days. But the need for trust in autonomous system operation for the DoD is paramount, because we're basically dealing with life and death decisions, literally. A lot of those systems are put to protect our people or to put our adversaries at risk, and so we can't take these decisions lightly. So it's a very, very high decision. And let me give you some examples of what programs who are using this in the space and the Air Force. Next, please. So this is just a very small sample of programs where we are, using autonomy and AI, and just like in the third offset strategy, we're looking at enhancing our battle networks, but now for multi-domain operations. And then, so if you look at the programs that I'm depicting here, the air battle management system, for example, we are working at rapidly creating communication networks, in an ad hoc fashion to allow closing the kill chain more rapidly and more robustly, so that we have multiple options and we're not limited by any adversary action. So this is, the ABMS. In Skyborg, we are looking at adding unmanned platform to the manned platforms so that we can create mass in the battlefield. For Golden Horde, we're looking at network collaborative autonomous weapons, and there we're looking at increasing the lethality of our munitions using collaborative autonomy and teaming at the tactical edge. And the Space Development Agency, for example, as one of the example in space, is looking at using disaggregated systems to create networks that provide communication and sensing in a more robust manner. So in all of those cases, autonomy and AI are critical to achieve our objective, but we also need to make sure that we can trust those systems. But defense is hardly the only domain with decisions that have high consequences, right? And Cap, I believe, at some point in your career, decided to take a short leave from the Air Force, and that you ran a small business where you used your expertise in AI to do some medical diagnosis. And maybe you can give us a little bit of a feel of what it was to be a small business like that, but also how other high criticality domains handle those questions of trust, and what lessons we could learn from those examples.
Yeah, if you go to the next slide. So yeah, I had just taken off my uniform after 20 years and 9 days in the Air Force, and decided to apply my wares to the detection of breast cancer. My mother had come down with breast cancer, and I was worried about my wife and my daughter, and now my granddaughter. And so I was interested in how to apply the things I was using in the military to find scuds in the first of the Gulf Wars to find breast cancers, because I had met with a physician, and the physician had showed me how they found my mother's breast cancer by putting up a piece of wet film on the back of a light box and picking up a magnifying glass and showing me this is where the cancer is. And I just couldn't believe in the 90s that was the state of the art. So my point is that if you're going to field AI in an area where it's life and death, you sort of have to figure out where does the technology fit. And so, being an arrogant son of a gun, an old AI professor, I assumed that I could just wire up an AI to outperform those humans that were using magnifying glasses. And so we put together, myself and some of my former students, put together AI solutions to analyze these images. In those days they were films, so we digitized them, put them into our computers, and analyzed them. And we had the assumption that if I showed them a ROC curve, the performance curve, a sensitivity versus specificities, the humans would trust the solution. In other words, see, there's the numbers. There it is. You should believe it when it says right there in that image there might be cancer. And much to my chagrin, not unlike my Air Force pilots, they didn't trust my technology. And they would always ask these same questions. And Dave Woods at Ohio State taught me these questions some years later. What the heck is your AI doing, and why is it doing it? And what's it going to do when this happens? Because I just don't trust it unless you can explain those things to me. There was no common frame there. And so myself and my engineers, we had this, hey, if I optimize my performance and outperform all my competitors, everybody's going to buy my solution. And that was not the case. But where we had our breakthrough and became commercially extremely successful is when we finally accepted the point that Eric made to you guys on the first day of this symposia. And that is, realize that what we were doing is we were putting a wingman into this battle space of cancer detection. The human and the AI needed to work together. And for us to optimize one without realizing its role in its team decision-making was a terrible tactical error. And we stumbled onto the answer. Long before Eric and I had these discussions, we stumbled on the answer that says you have to jointly optimize the AI with the human in that space. And so we did that using, lots of really interesting techniques in those days to find common feature spaces so the human would have a mental model of what the AI was doing well and when it did not do well. And I was getting, instead of comments like, what is it doing, was, hey, you never miss those. I better look back there. And they looked back and found the cancer. Or you always get those wrong. I'm going to ignore you. There was this interpredictability going on. The point I'm trying to make to you is, as AI developers and autonomy systems creators, is we have to adopt what Eric was teaching you the other day, and that is jointly optimize our solutions if you're going to get the trust. Now, that is an unsolved space. If you go to the next slide, for that reason, in Act 3, we adopted early on the idea that we can't just do basic research or have our Air Force Office of Scientific Research colleagues do basic research and have them throw it over the fence and then do the development. So we developed an extremely intimate relationship with our AI performers. And so you see on this graphic right here, and these aren't just images thrown up. These are people that we actually have worked with. In the top left there's Jan Lee Kuhn. One of our Act 3 engineers actually embedded with Jan and his engineers up in New York City and worked side by side with them. Okay. And Tom Mitchell and down in the bottom right, Patrick Winston, before we lost him, we actually have gone into their laboratories, sat side by side with them and held workshops. Same thing with Josh Tenenbaum down there in the bottom left. Charlie Pfefferman, Fuels Medal winner on the upper right. Vapnik there in the middle has come into Act 3, spent days with us. All of this is through the use of, through the work, very interesting work of our colleague Doug Ryken from AFRL there on the right, who was a Marvin Minsky student. The point I'm trying to make to you is we work extremely closely. There's nothing we do that isn't driven by the world's best researchers, including those here within Act 3. And we're driving the technology forward just as fast as we can and fueling it just as fast as we're inventing it on really tough problems in those areas I mentioned, aligned with those strategic goals. And that makes it extremely exciting. And so as I look at where we're at, I got to tell you, I'm very happy with where we're at, but I'm more excited about where we're going. So JC, if you could sort of give us a view of the things that you see coming that are exciting you, and then I'll do the same.
Yeah, thanks. I mean, this is, you're absolutely right. This is super exciting research, and I certainly believe we need to do more of it. One of the things that I'm excited about on this research is really to start developing autonomy that is not as context sensitive as today's autonomy. Today's solutions tend to be effective for a very narrow context, and they're not very good at doing context switching. So I think that's one of the areas that we really have an opportunity to do, is developing context aware and context adaptable, or as you would say, I think, flexible solutions. And in my view, one of the most promising approaches is really this hybrid approach, where we are mixing semantic or good old-fashioned AI with the statistical or deep learning AI, and really trying to get the benefits of both. And I think this will allow us to work with less data and increase the robustness of the solution as well, but also give us the confidence that the system is actually learning what we wanted it to learn. So, as an engineer, I'm also excited by the prospect of using these tools to make our jobs easier, and really to deploy those tools in particular to help digitize the rest of the world that was not born digital, and I think this really will bring opportunities that are associated with the next big thing, in my view, that's coming down the pipe, which is augmented reality. I think augmented reality is going to have a revolutionary effect on the way we consume data, on the way we're going to be able to merge the real and digital world, and that's going to change how we learn, how we share the work with the AI. And the last point I wanted to kind of make briefly is the role of AI today is as an assistant. And I was pleased to see somebody else use the word apprentice for AI in a report. That's really is, I think, a good way of looking at how we can deploy AI as an apprentice. It can do some a simple task right away for us and remove the burden. It can also support us as an assistant for more complex tasks. But really, I believe today's AI is there also to observe and learn from the masters, from the humans, and then able to do that. But in addition to being an apprentice or maybe a teammate, I think AI can function as a coach. And one of the things I would like to encourage people to think of is it's not going to be enough to make the machine better or to make the human-machine team better. I think we need to also look at how we're going to make the humans better. And having the AI function as a coach, observe your performance and give you some feedback, constructive feedback. And maybe every now and then say, you haven't done a crosswind landing in a long time. You should take this one. I'm not going to do it for you. I'm going to let you maintain your currency, your proficiency, so that when things go bad, you are actually a valuable backup instead of somebody who is completely rusted. So that's kind of the type of things that I believe are exciting me to continue to work. And we only have like 3 minutes left. So I will yield the rest of the time to you, Cap, to cover the couple of topics that you're working on that are very exciting as well.
So you go to the next slide. A couple of things I just want to make you aware of, you may not have heard. We recently, for the first time, out at Edwards Air Force Base, flew an Air Force jet being controlled by a deep reinforcement learning AI bot. And so that Learjet you see on the bottom right of the picture, the bottom center is the team that was out at Edwards. The AI deep reinforcement learned AI bot controlled that Learjet doing mission related tasks in tandem with the F-16s. That it's pretty exciting to me. That's an inflection point. That was in March of this year. We're going back out there in September for subsequent flight tests. And then in the bottom left picture, you see the test pilot. His hands are on the controls, but just shadowing the controls. Really interesting experience of training AI in a simulation environment and then turning it loose in the world where things are not the same. It's an extremely exciting time. We believe strongly that air supremacy is a strategy competition, and if in fact this follows the same path as other strategy competitions, whether it's chess or Go or whatever else, then you would suspect that an AI should be able to develop strategies that could defeat a human adversary, and that's what we're investigating under this effort. It's a really exciting time, and again, we're always looking for the best ideas out there in this space, because we are at our core an air supremacy force, that is the Air Force. We also, of course, work for the Space Force, and we're looking to apply these same techniques to our space platforms, that is autonomous control. If you have ideas in these areas, everything from league play to sim to real to sim, those areas, we're always anxious to talk to you. If you go to the last slide, please. With respect to things that excite me the most, as JC said, our current solutions are fragile, they're brittle. We've become extremely good at what we like to call observation AI. You give me enough examples, if the data is similar enough to those examples, I can do a pretty good of telling you what they are. We're getting better, as we did in that example I just showed you, at doing action AI, where if I can actually train this system in the environment, giving it rewards, I can teach it to do things that are useful. But where we're failing, where we currently are searching, in JC's terminology, that unexpected query, if you will, is what Patrick Winston used to tell us is the imagination or predictive AI. And the picture on the right is the one that our colleague Patrick used to always talk about. Ask any AI, what happens if I carry 2 pails of water and run down the hill? Okay. They'll search Google, they'll get lots of things about pails of water and Jack and Jill and running, but they can't imagine what's going to happen there. That is, the water's going to slosh around and you're going to get wet. We are very poor at creating AIs with world models that can create these simulations, these imagined futures, and thus sort of play them off against what they should and should not do and why. That's the future. And that's where we're pushing hard in the research part of Act 3. So I want to finish up by saying we find this an extremely exciting time, but we also find it, part of our excitement is the people we're working with. So if you have ideas in any of the areas that JC and I have talked about, engage with us. We work with anybody we can find. Ideas are not unique to individuals, but they seem to come out when we have these extremely diverse groups. And so if you have expertise in some area or just some interest, please engage. And thank you very much.
Thanks, Cap. That was awesome.